We have a MacBook Air. It's dead. It's no power. It's an A14666. So let us. So this one we can, because it's not. We confirmed that it's not liquid damage. So we can connect our charger to see what we have. So connect our MagSafe 2, and we didn't have communication. So as you guys can see, there is no communication whatsoever. Now, the first approach to a repair like this one without communication is you want to confirm if the device is in any way in a deep sleep. Okay, so the two things that's at the very basic level, and or if it's in any type of reset mode. So what you want to do is first thing, take out the back cover, disconnect your battery, and try again. See if you have communication. So usually in this state, your SMC, can you please reduce the sound? Your SMC is not engaging in this state. So we want to first disconnect our battery. Now let's try again. Okay, we still don't have charger communication. So the next thing we want to do is we want to see if we have voltage in. So let's see what we have on our PP3B42. Okay, we do have voltage in. That tells us, so that's PP3V42 is present. So what that means is we have PPDC in. So let's quickly open up the board view. You guys have an idea of, this is 80-00165. It's a 2015-2017 logic board. Remember, in my previous video, I did mention to you guys one of the ways you can identify 2013-14 over 2015-2017 is a JTAG connector. When you see the JTAG connector to be small, then that's a 2015-2017. The board ID for 2015 and 2017 are the same, 820-00165. Okay, so now this is our board view. So what we have to confirm is we have to confirm that we have PPDC in. So PPDC in is present, which is why we have PP3V42. If PPDC in was not present, we will not have PP3V42 because PP3V42 it's created is an extent is it's a rail that is created from your PPDCN. If there is no PPDCN, your PP3V42 will not be present. So we have confirmed that PP3V42 is present, which means our PPDCN is okay. So the reason why we had to measure our PP3V42, because we don't have charger communication, it may be that there is no power from the charger onto the machine. But the fact that we have PP3V42, it means that we do have power from the charger onto our machine. So our issue is not our charging circuitry. Our issue is not our input voltage. Our input voltage is just fine. Now, in terms of our I/O board cable, the I/O board cable has functions that are not directly linked to the machine being powered. So what I mean by that is whether the I/O board cable is faulty or not. Yes, you may not have charger communication in terms of the LED, but your PP bus is going to stay. When you measure your PP bus will reflect 8.5 to tell you that your SMC is running, and you will have a spinning fan. I mean, your fan will be spinning. But in this case, we have charger disconnected. We have our charger. We have PP342, but we still do not have fan spin, and we don't have charger communication. The next thing we want to do is we want to see what we have on our PP bus. Let's see if our PP bus it's 8.2 or 8.5. So let's switch to 200 volt in our voltage, our voltmeter. Let's see what we have. So that is 8.1. So 8.1 tells us that there is no engagement from the SMC. The next thing we want to do is we want to disconnect the charger, and then take out the battery and see if now sometimes the keyboard can reset the SMC. Uh, I'm just going to show you guys what I mean by that. So this is the key. Are you capturing this? Yeah. So this is the keyboard connector. This is where the trackpad cable that so the MacBook Air design is such that the keyboard is connected to the trackpad, and the trackpad then connects to the logic board through a trackpad cable. Now, on the connector on the logic board, which is J4800, on there we will have SMC reset L. So SMC LSOC underscore reset underscore L. We have it. So basically your keyboard is able to reset, which is to pull down basically to pull down the SMC into reset mode. So the next thing we want to do to rule out that as not being the issue, to rule out that our keyboard is not pulling down our SMC, we will disconnect the battery, which will then give us enough room to disconnect the trackpad cable, which would then obviously disconnect, which means our keyboard will also be disconnected. So right now, if our keyboard is pulling our SMC reset signal down, then this should fix the issue. Now let's check again and see where we are. Okay, so we still do not have communication, and we will still be measuring 8.1, which basically tells us that our SMC is still not communicating. Now, let us see what we have on our SMC reset L. So to do so, now we have we have gone through the basics. Let's now take out our logic board and check out our SMC reset L. And also on the other side of the board, we will also get to visually see how our SMC look, if there is some kind of a liquid spill around the SMC, or if there is a reason why our SMC signal it's low. So two things we will be looking at now. Number one is we'll be looking at the SMC itself, and then number two is we'll be looking at the reset SMC reset underscore L circuitry, which is R which is going to be R51 5110. We will be looking into that as well. So we want to understand why our SMC it's the SMC it's reading 8.1 instead of 8.5. So we want to take out our logic board so that we can get to the other side of the board, and then we'll have a better understanding of exactly what is happening on our board. So screws are out. Now we're disconnecting the cables. Okay, the fan, usually you don't have to take out the fan. The fan screw should remain. So I'm just gonna put that back. Okay, now we can put aside the shell, and then let's get it to understand what is wrong with our logic board. Okay, so this 1.8 tells us that it's a 2017 board, and also um, the webcam webcam processor that's used here also tells us the type of chip they use for the webcam processor also tells us that this is indeed a 2017 logic board, and also the CPU configuration is a 1.8. So that also it's a giveaway to tell you that this is a 2017 logic board. Okay, now what we want to do is we want to give it a visual inspection to have an idea of what is happening. And then the next thing we want to do is we want to measure our SMC reset L signal. Let's see if that is low. So we can get that. Let's see. Okay, so me flip the board again. Um, this other side of the board. Okay, like this. Now, let me see. And then like this. Okay, like this. Mm. Okay, U5110. Let's see what it's. So what we want to confirm now, it's SMC reset L. Let's see if that signal is low. Because if that signal is low, that explains why our SMC is not running. So let's see if that signal is low. We can measure that signal here. We can measure that signal just here. We can measure SMC reset L here. See that? We can measure SMC reset L here. So let's connect our charging port. Connect our charger. Okay, with all of the cables disconnected, let's just confirm that we have PPDC in again by confirming if we have PP3V42. Okay, PP3V42 is present. Now let's see SMC reset L. Let's see if that is present. We can get that on this pad here, and SMC reset L is present. Now at this, so let me just switch this back to 20 volt. So here that tells us that SMC reset L is present. So at this point, we know that we are not having issue with U5110. Now what we now have to look out, it's solely the SMC itself. So we now want to understand why the SMC is not engaging. So SMC reset L is high. So the next thing we want to do is we want to give the SMC a slight reflow. So we want to give the SMC a slight reflow. So like I said, there are two things that we're supposed to um, the two things that we're supposed to look out. Number one is the secretary of the SMC reset signal, which is U5110. If U5110 pulls down the SMC reset signal, obviously the SMC will be in reset mode, and if the SMC is in reset mode, this is the behavior that we will get. There will be no engagement, the machine is not going to power on, there will be no fan, there will be no charger communication, there will be no LED, and the PP bus is going to be sitting at 8.1 instead of 8.5. So after we ruled out that the SMC reset error is not being pulled down by our U5110, the next thing we want to do is we want to look at the SMC itself. Now, the first thing we want to do is we want to basically remove the edge bonding of the SMC. This is the SMC chip. We want to remove the edge bonding of the SMC, and then I also see a bit of a bit of corrosion around the SMC. That can also explain having dirt underneath the SMC will prevent the SMC from functioning. So the first thing we want to do is we want to remove the edge bonding. After we remove the edge bonding, we will be applying flux and then give the SMC a slight reflow. In a situation where the reflow doesn't fix it, the next thing we want to do is we want to remove the SMC completely and see if there is a broken pad underneath the SMC, the SMC chip itself, the SMC solder pads. So if the SMC itself after reflow still doesn't work, we take it out to try to see if the SMC has that is preventing it from working. If everything fails, the next thing we'll have to do will be to completely replace the SMC. So right now we just want to give the SMC a reflow, and then we take it out from there. So whatever form of dirt that is underneath the SMC should go off with the reflow that we're doing. Now, as you understand that we are not just reflowing the SMC, it's the diagnostic steps, the steps that we took to isolate the issue led us down to the SMC itself. So you don't just go start reflowing the SMC and you don't have a reason to do so. And when you have a problem like this one where you do not have your charger engaging your machine and your your PP bus sitting at 8.1, it doesn't also necessarily mean that definitely it has to be the SMC that needs reflowing. You have to basically narrow it down to exactly what the issue is, and then you address accordingly. Okay. We have give SMC a slight reflow. Oh, by the way, this was this was the board that was liquid damaged. So it's now gone through the cleaning process and it's been dried out. And you see it's looking really really different. So it's almost like a new logic board now. So this was the 15 inches A1707, the one that we had accessed, and we were supposed to reach out to the client to confirm if they give a go ahead for the event. They have given a go ahead for the device to be fixed, and the device, the board has gone through a deep process cleaning, and also it's gone through a method of drying as well. The board is it's pretty much like brand new right now. So we will let it cool and then go over the board and see what what stage the board is in, and then we'll take it off from there. Usually, when you the before and after, the before the board and after it's clean, when you see it, it's almost impossible to believe that that the board is actually this, this clean. I can see a couple of components that needs to be addressed. I'm just gonna put a mark in place so that I can go there. Yeah, and then needs to be looked into. I'm not working on this right now. I'm gonna first finish up with the Macbook Air before I I go back to this. I'm just creating those marks so that when I'm troubleshooting and then I have a reason to if I and then I have a reason or I have a rail that is missing that may be connected to that section that I marked out, then it's easy for me to start from there. Okay, I'm just gonna put this aside. Let's continue with our MacBook Air.
So when you say deep sleep, is it something happens all the time
No,
with the bodies?
no. So if the machine was in deep sleep with the battery disconnected, then that should address the issue. If it was in deep sleep with the battery disconnected, that will address the issue, and then you have a functioning machine again. But the fact that the battery is disconnected, that rules out the, the part of the machine being in deep sleep. So the next thing we needed to do was to see if our keyboard was pulling down the SMC reset L signal. The keyboard wasn't doing that. The next thing we needed to do was to see if our SMC reset signal circuitry was the problem. That also was not a problem, which then leave us to one section and one section only, which is the SMC itself. Now, by the SMC, we found a bit of corrosion around the SMC, so that explains why the SMC is not engaging. So we had to do a reflow because a reflow will obviously uh, allow the SMC to kind of reconnect on your board in case there is any form of partial communication underneath the SMC. So now that we've done a reflow, the next thing we want to do is personally when I'm troubleshooting my logic board, I don't want to see so I disconnect the fan. I want my multimeter to tell me the state I'm into because I don't want to, be looking out for a fan spin and I don't get a fan spin. It just gets very depressing. So what I usually do is when I'm working on a device like this, I disconnect my fan and then the improvement of the changes on my measurements will obviously tell me that okay, if I am good or not. And if I'm not good, I just continue until I am certain that yes, I am now in SO state, or I now have the required voltage to go into SO state. Then I will connect my fan, because I don't want to get my fan connected and put my hopes up and I don't get a fan spin. So the next thing we want to do now is we want to connect our charger again and see if we have any improvement. So charger is connected. Let's see if we have our PPDC in. We can confirm that by making sure we have PP342. And yes, we have PP342. Now the next thing we want to do is we want to say what we have on our PP bus. Now what we have on our PP bus will tell us if our reflow is successful or not. If we have 8.8, if we have 8 point, if we have 8.1, then obviously it's not successful. But if we have 8.56, then we know that our reflow was successful. So let's see what we have. 8.1. Nah, we still not where we want to be. Let's put it on 20 volt. 8.18. Yeah, so we should be at 8.58 or so. Okay, now let's take out our SMC and see if we have that, if there is a missing part underneath the SMC. So like I said, if reflow doesn't fix it, we may have to replace the SMC. And when you're replacing your SMCs, 2015s and 2017s can be interchanged. You can use a 2015 SMC on your 2017 MacBook Air, no problem. And also 2013, 2014 can be interchanged. So you can use the 2013, 2014, you can interchange the SMCs. 2015 and 2017 can be interchanged. 2011 MacBook Air stands alone, 2012 MacBook Air stands alone, and 2013, 14 stands together. Okay, so just like we said, so I'm just going to show you guys, if you can zoom in. So you can see here, so this, so this section, you see this is the dead that's under, you see that? Yeah, so that was preventing communication. So if we find, let's just see what is in that section, what that section is. So this is the section that, so we have 61 wire in that section, we have that signal in that section, not connected. So basically, we had a chunk of, so this was why there was no communication. I don't know if you got that, yeah? So that was why there was no communication. So what we just want to do is we want to clean it, and then put back the same. We don't have to replace the SMC yet, because we can clearly see that the reason why there was no communication is not that the SMC pad, it's not that there's a missing pad on the SMC itself, or where the SMC is supposed to be soldered onto, but there was a small chunk of that underneath the SMC, and the particular pad that was kind of affected was, let me see, 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay. 1, 2, 3, 4. 1, 2, 3, 4 is NC, not connected. Okay, so we will have, since the depth is out of the way, we want to put back the same, yeah, without having to replace it. So let's put it back now, and then we hope to have changes. So if putting it back, and by the way, we don't have to reball it, because my the balls are pretty much in place. Um, Now, if putting it back does not address the issue, the next thing we want to do is we want to replace the SMC completely, and we should have a functioning board afterwards. Because what we really need now is to get our SMC communication active, at the level of our PP bus, and then we'll be good to go. Now, obviously, when you're putting the SMC back in place, but you have to be aware of the orientation. You have to orient it accordingly, otherwise, you will not have a functioning chip. How far with the 13 inches? Okay. And this guy's coming today. Okay. And then so are you so okay. So that is in place. We give it a bit of time to cool off, and then we test it. So if we test it, and so usually if so what we will be doing is we will test it and see if it works. If it doesn't work, we just confirm that it didn't work. The, the 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 reason why it's not working is not because the SMC was not properly installed. We confirm that. If we confirm that the SMC was indeed properly installed but it's not working, then that will tell us that we just need to replace the SMC. Then we will go ahead and replace the SMC. Now, like I said, to replace the SMC on this model, you need to use either 2015 or 2017. You cannot use a 2013 or 2014 SMC. If you do so, you have to reprogram the SMC to work on the 2015, 2017. So let's try again, see what you have. First and first, we want to see if we have our PP3V42. Yes, we have our PP3V42. Next thing, let's see if we have what we have in our PP bus. 8.6, nah, still not working. So 8.16, nah, we're still not where we need to be. We need to be 8.50 something. So yeah, we'll have to put in another SMC because clearly our SMC is not working. Okay, so that is out. Let's grab a dono board with an SMC and yeah. Okay, just before we let's just confirm that this SMC works. Let's see what we have on our PP bus. 8.6. Yeah, that's exactly what we should be getting. So, the SMC here, it's fully functional to an extent. I wouldn't say fully functional because, yeah, it may be that our source rail may be missing as a result of the section of the SMC not being active. But I think that that will not be the case here. Let's just, yeah. So let's get this SMC to the other side. Okay. SMC is out. Okay, let's see. Do we need to roll it? Let's see, let's see. Not really. Okay, we don't have to. Looks good. There is a part that is missing underneath this. I'm not sure if you guys can see that. And it's a part missing here underneath the SMC. So I want to find out what that part is. Hopefully it's NC, which is not connected. Uh, it's this sys1 wire. Oh no, that's not good. Okay. Uh, so this part is missing. But that's not good. We need that for our one-wire communication. Um, No. So with this SMC will start the board, but there will be no one wire communication, which will mean that the green light and to amber light on the charger It's not going to work with this SMC. Uh, okay. Yeah, because we don't have that. Okay. We have to grab another SMC. This is not going to work for us. Let's just put that back. If not for that pin, I mean, this SMC can get the board started. I mean, we will be in SO state with this SMC, but we will still be lacking in our function. So let's get another SMC. Hmm, I'm not sure what state this SMC is. Let's take it out. Okay, the balls underneath are complete. We might just need to do a little bit of add and remove here, just a little bit. Okay, so okay, let's do this. We want to smash it in a way that it kind of reduces the balls underneath it. Let's do this. So smash it like that. Okay. Yeah, this is pretty much what we want it to be. Yeah, that's okay. Okay. Now, it's pretty where I want it to be. No, it's moved. I didn't want it to move. Let's see if we can get it to move back and forth. That doesn't look good. We may have to remove it and just redo it because it moved to the right, and moving it back in that state might kind of roll some balls underneath it, and then you will have an improperly installed SMC. So let's just get it to cool down. First and first, let's see if our PP3 before 2 is not shorted to ground as a result of that. What time is it? 6:56. Okay, we're almost done here, and I'm super hungry. Okay, let's see what PP3 before 2 is. Is it shorted? Nah, it's not shorted. Okay, so let's see. I doubt that SMC was properly installed because I could see the way it moved. So let's see what we have. PP3 before 2 present. Okay, switch back to voltage. PP3 before 2 present. Yeah, present. PP bus, what do we have? 8.1, 8.8. Okay, let's see what we have. Okay, 8.58. That's exactly what we want to have. Now we should be hoping to have our SO rel being present. Let's see if that's the case. Okay, it doesn't seem like we have our S. Yes, that is our SO rel, 5 volts. So at this rate, we should be getting a fan spin. This is when I like to connect to my fan. Only when I know that my multimeter said it's a go, then I can connect my fan and then expect a fan spin. So let's see. Where do you guys? Yeah. That is my fan spin, and that's a fan spin. Let's hope it's not going to start and stop, because so if it starts and then stop. Oh yeah, I was going to show you something, Peter. So just take note of the fan. So there is a point where the fan, so the fan kind of starts. So this is, so when you if you look at the chart of the fan, so it's going to start like this a little bit, and then there will be so from this point to this point is a little, and then from here it's going to switch different. Now from that point it switches. There are two things that will happen there. The machine, if that machine is not going to boot, that process will continue like that.
Takes the same speed.
Yeah. Now, if the fan at that point also where the fan is supposed to switch to make it to kind of run faster, the fan, if the fan stops at that point and start again, it tells you that that machine is not going to post. So now I'm just gonna. I want you to look at this. You see that the fan will start at a particular pace. You see, it's start at a particular space. Now you see, it's gonna at some point. You see, go away. Now it picks up.
Yeah.
So that tells me that this board is posting. Now, if at the point where it was supposed to pick up, where it changes pace, if it has stopped and then starts again, it just tells me that that board is not going to post. So now this tells me that we are posting. What we just want to do is let's connect our screen to see if we have an Apple logo. Yeah, so pretty much. Okay, so the anticipation of a fan spin is something you don't want to go through, because there's this build up of and sometimes you just get disappointed when you look at the fan spin. So I usually do not. So that is an Apple logo, and we have a fully functioning machine. So now this is done. The board is going to go through a cleaning process, and then after that, the board will then have to go into the shell. The testings will be done, and then the client can be informed about the device being ready. So basically, you guys saw the process that we took. We started from start, the assessment, the diagnostics process that we follow from start to finish. So you don't just engage in a particular secretary and try to rework that secretary. You have to have a reason to be there, and you have to have a reason to blame. There has to be a thought process in where you are, what you're doing, and why you're doing what you're doing. You don't just do. No, you saw the process that we had to go through. We had to go through kind of um, uh, 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 going through the process of having to make sure, okay, this confirm, no, not confirm, yes, no, not, and then we move until we got to the point of the SMC. We reflowed the SMC. That didn't solve the problem. We took out the SMC. We cleaned underneath the SMC, and then we restored it back. That also didn't solve the problem. Then we had to eventually replace the SMC with another one. And then I said that with the SMCs, 2015, 2017 for MacBook Airs will work the same. 2013, 2014 will work the same. 2011, it's on its own, works on its own. 2012 works on its own. So 2011 will be 2011 alone. 2012 will be 2012 alone. 2013, 2014 can be used interchangeably. 2015, 2017 can be used interchangeably. Thank you guys. This is going to be the end of the video. This is going to go through the testing phase, and then yeah, the client can be informed about a happy working machine. Thank you. See you in the next video.